Hello and welcome to Stories of Science. Here, we look back on humanity's long journey to understand the world. The questions, the failures, and the breakthroughs that slowly changed how we see the universe and ourselves. We tell science as stories. Apollo 16, unlocking new scientific frontiers on the Moon. Apollo 16, a historic journey to the Moon's hidden secrets. On April 16, 1972, Apollo 16 blasted off, heading straight for the Descartes Highlands on the Moon. But this wasn't just another lunar mission. This time, the goal wasn't just to snap some photos, it was to peel back the mysterious layers of the Moon's surface and explore what lay beneath. Apollo 16 wasn't just a scientific mission, it was a monumental step in humanity's quest to venture deeper into the cosmos. Imagine this: for centuries, humans observed and speculated about the Moon, but many of its mysteries remained unsolved. Only now, with Apollo 16, were we ready to truly uncover its secrets. This mission was designed to go further than any before it, diving into unknown territory and pushing the boundaries of space exploration. 3 astronauts were chosen to carry this heavy burden. Their mission, not only to collect lunar samples but to drive the Moon rover for the first time and explore the remote, almost untouched region of the Moon known as the Descartes Highlands. This was a challenging, high-stakes journey, one that promised to uncover a wealth of information about the Moon's history. Unlike previous Apollo missions that landed on the flat, relatively featureless plains, Apollo 16 chose the Descartes Highlands, a rugged, scientifically rich area that had long been overlooked. Scientists believed this region could hold the key to understanding the Moon's early geological activity and its formation. The landscape was far from easy, but its rough terrain was exactly what scientists needed to dive deeper into the mysteries of the Moon's interior. The selection of this specific area wasn't random. Even before the Apollo program, scientists had carefully analyzed different lunar regions. They identified the Descartes Highlands as a crucial area for understanding the Moon's early geological history, perhaps even its origin. By studying the rocks here, they hoped to unlock secrets that could help us understand the Moon's formation and its connection to the Earth. But the challenges were immense. The region was far from the flat, familiar terrain of earlier landing sites. For the astronauts, exploring this area meant dealing with steep, jagged rocks and a landscape that was more treacherous than any they had faced before. The difficulty of collecting samples and conducting geological experiments was high, but the value of what they could uncover was worth it. Each rock, each grain of soil, could reveal the Moon's ancient history, answers to questions that had puzzled scientists for centuries. Apollo 16's mission wasn't just about collecting lunar samples, it was about gathering the pieces of a cosmic puzzle. The samples collected from the Descartes Highlands could shed light on how the Moon transitioned from a molten ball of magma to the solid surface we see today. This wasn't just rock collection, it was a deep dive into the Moon's geological makeup and a crucial part of humanity's journey into space. Despite the region's challenges, the scientific value of the Descartes Highlands couldn't be overstated. The lunar samples collected there provided scientists with critical clues about the Moon's composition, and may even help explain how the Moon and Earth and the entire solar system evolved. The Apollo 16 astronauts were standing on the edge of history, ready to unlock these secrets. Meet the heroes: John Young, Charles Duke, and Thomas Mattingly. Now, let's take a closer look at the astronauts who took on this monumental task. First, there's John Young. John Young was born on September 24, 1930, in McKinney, Texas. Raised in a supportive family where his father was a small business owner and his mother a homemaker, Young developed a fascination with flying and space exploration from an early age. His dream was to become a pilot, a goal he would eventually achieve after high school, thanks to the encouragement of his father. Young attended Southern Methodist University in Texas, where he studied engineering. After graduating, he joined the U.S. Navy in 1952 and quickly became a test pilot. His flying experience laid the groundwork for his future with NASA, where he joined the astronaut program in 1962. Apollo 16 marked Young's third space mission, and his role as mission commander was a significant one. He didn't just oversee operations, he was the first astronaut to drive the lunar rover on the Moon. Known for his calm demeanor under pressure, Young's leadership during the mission earned him widespread admiration. His contributions to the mission's success made him one of the most respected astronauts in history. After Apollo 16, Young continued to work with NASA in various leadership roles, eventually becoming the deputy administrator. He also commanded the first space shuttle flight, Columbia, and flew on 6 space missions in total. John Young retired in 2004 at the age of 74, leaving behind a legacy that continues to inspire future generations of space explorers. Next up, let's talk about Charles Duke. Charles Duke, born on October 3, 1935, in Columbia, South Carolina, came from a military family. His father was a military officer, and his mother worked in education. Raised in an environment that emphasized discipline and education, Duke developed a deep interest in science and math, particularly in aviation and space exploration. As a child, he even built model rockets to simulate launches, although they didn't exactly make it to space. Still, this sparked a lifelong passion for space. Duke attended the U.S. Naval Academy at Annapolis and later joined the Air Force, where he became a pilot. His impressive flying skills and academic background made him an ideal candidate for NASA's astronaut program. Duke's journey to Apollo 16 was fueled by his military experience and deep understanding of aerospace engineering, both of which helped him excel as a NASA astronaut. As an astronaut on Apollo 16, Duke played a pivotal role in the mission, contributing to the geological exploration of the Moon's surface and helping to collect valuable lunar samples. His enthusiasm and expertise made him an essential part of the Apollo 16 team. Conclusion: a legacy of exploration. Apollo 16 was more than just another mission, it was a leap forward in our understanding of the Moon and the broader solar system. Through their courage, skill, and dedication, astronauts like John Young and Charles Duke helped shape the future of space exploration. And their work didn't just bring back lunar rocks, it helped lay the foundation for the future of humanity's exploration of the stars. So, the next time you think about the Apollo missions, remember, it wasn't just about getting to the Moon, it was about opening the door to the universe. Apollo 16, the journey to uncover the Moon's secrets. On April 16, 1972, Apollo 16 lifted off, destined for the mysterious Descartes Highlands on the Moon. Unlike its predecessors, this mission wasn't just about landing and taking pictures, it was a full-on scientific exploration to uncover the hidden secrets of the Moon's surface. Apollo 16 wasn't just a mission, it was a leap into the unknown, a journey that would change the way we understood our nearest neighbor in space. This wasn't just another space mission. It was an opportunity to explore a region of the Moon that had never been touched by humans before. The Descartes Highlands weren't your typical flat lunar plains like those of previous Apollo missions. These rugged highlands were considered a gold mine of geological information, holding clues to the Moon's history, its formation, and possibly even its connection to Earth. 3 astronauts were chosen to embark on this monumental task: Commander John Young, Lunar Module Pilot Charles Duke, and Command Module Pilot Thomas Mattingly. While Young and Duke would walk on the Moon, Mattingly would stay in orbit, overseeing operations from the command module. This was Young and Duke's second trip into space, but it would be Duke's first lunar landing. At just 36 years old, Duke became the youngest astronaut to set foot on the Moon. On the Moon, Young and Duke weren't just there to collect samples, they also became the first humans to drive the lunar rover. They navigated the harsh, barren landscape of the Descartes Highlands, collecting rock samples that would provide crucial data to scientists back on Earth. Duke's upbeat and humorous attitude was a breath of fresh air for the team, lightening the mood during this high-pressure mission. After Apollo 16, Duke didn't just stop at the Moon. He stayed with NASA, taking on leadership roles. In 1975, he participated in the Apollo-Soyuz mission, the first joint U.S. Soviet space mission, further cementing his legacy in space exploration. He later became a speaker and consultant, encouraging young minds to reach for the stars and pursue their own space dreams. Next, we meet Thomas Mattingly, the man who kept the mission's operations in check from the command module. Born on March 17, 1936, in Virginia, Mattingly's childhood was anything but conventional. His father was a Navy officer, so the family frequently moved, which taught Mattingly the value of adapting to new environments. He once had a hobby of flying paper airplanes, which sparked his lifelong passion for aviation. Mattingly graduated from the Georgia Institute of Technology with a degree in aeronautical engineering and quickly became a Navy pilot. His outstanding performance in the Navy led him to NASA, where he was selected as an astronaut. Although Mattingly didn't set foot on the moon like Young and Duke, he played an absolutely critical role in the Apollo 16 mission. He was responsible for piloting the command module, ensuring that communication between the lunar module and Earth was seamless, and maintaining the spacecraft's systems during their journey. Mattingly's most famous spaceflight was initially meant to be on Apollo 13, but he was replaced due to illness. Though he missed that mission, he made up for it in Apollo 16, playing a vital role in its success. Mattingly continued to serve at NASA in key positions and was heavily involved in the Space Shuttle program. He retired in 1985 but continued contributing as a consultant and speaker in the space community. The historic launch and journey to the Moon. At 12:54 p.m. local time on April 16, 1972, Apollo 16 launched from Kennedy Space Center. The crew commander John Young, lunar module pilot Charles Duke, and command module pilot Thomas Mattingly boarded the mighty Saturn V rocket for a mission that would take them to the rugged Descartes Highlands on the Moon. This area had long fascinated scientists, and now, they were about to explore it up close. The Saturn V rocket was a behemoth, standing 111 meters tall, 10 meters wide, and weighing 3,000 tons. The fuel it burned in just a few seconds generated 7,000 kilotons of thrust, an incredible amount of power. The launch wasn't just a feat of engineering, it was a high-stakes operation. The precision required to get the spacecraft into the correct orbit and dot with the Moon was like threading a needle in the dark. As soon as the launch sequence was completed, the astronauts were on their way to the Moon. The journey from Earth to lunar orbit took about 3 days. The Apollo 16 crew traveled at speeds of approximately 4,000 kilometers per hour, covering the 384,000 kilometers between Earth and the Moon. During this time, they made constant adjustments to ensure the spacecraft stayed on course. By April 18, just 2 days after launch, Apollo 16 entered lunar orbit. At this point, the crew was just 160 kilometers from the Moon's surface. But they weren't landing yet. They still had to scout the Descartes Highlands, an area far more rugged than the smooth plains visited by previous Apollo missions. Their landing site would be crucial for the scientific objectives of the mission. The historic lunar landing. On April 20, 1972, the lunar module, Orion, successfully touched down on the Moon. John Young and Charles Duke began their historic moonwalk, making scientific history as they explored the Descartes Highlands. The terrain wasn't flat and easy, but the astronauts managed a perfect landing with the help of NASA's precise technology. Young and Duke's stay on the Moon lasted 71 hours, the longest of any Apollo mission at that time. This gave them more time to complete a thorough geological survey and gather samples. They didn't just walk around, they drove the lunar rover, covering a significant distance and discovering new lunar features that had never been seen before. Every turn of the rover was like peeling back another layer of the Moon's ancient history. One of the most remarkable aspects of Apollo 16 was that, in addition to collecting lunar rock and soil samples, the astronauts set up a series of experiments to learn more about the Moon's geology and atmosphere. The data they collected would provide insights into the Moon's past and its connection to the Earth. The return journey. After 3 days of exploration, Young and Duke had to leave the Moon. They reascended to lunar orbit, where they reunited with Thomas Mattingly in the command module. With their 94 kilograms of lunar samples safely stowed, the crew began the journey back to Earth, ensuring that the mission's scientific goals were accomplished. As Apollo 16 safely splashed down in the Pacific Ocean on April 27, 1972, it marked the end of another successful mission in the Apollo program. But more importantly, it opened new doors for the future of lunar exploration. The samples and data brought back by Apollo 16 continue to be studied to this day, revealing even more about the Moon's history and the broader story of our solar system. Apollo 16, the mission that pushed the limits of science and space exploration. After 4 intense days in space, Apollo 16 began its return journey, a crucial final phase of the mission. The astronauts had to ensure that the spacecraft would safely re-enter Earth's atmosphere and make a controlled landing. And boy, this wasn't a walk in the park. As they re-entered the atmosphere, the spacecraft would be traveling at a speed of 27,000 kilometers per hour. Talk about high stakes. On April 27, 1972, Apollo 16's command module successfully re-entered Earth's atmosphere and went through the process of heat shield re-entry. The exterior of the spacecraft was coated with special heat-resistant materials designed to withstand the extreme temperatures generated during re-entry. The astronauts had to hold their breath as the spacecraft descended, but they were finally safe when the command module landed in the Pacific Ocean about 1,500 kilometers from the Hawaiian Islands. The mission lasted a total of 8 days, 3 hours, and 17 minutes. One of the most important aspects of Apollo 16 was the collection of lunar rock samples. These samples would provide critical data for understanding the Moon's geology, origin, and surface history. The astronauts collected a total of 94 kilograms of samples, which included a mix of lunar rocks, soil, and various mineral compositions from the Moon's surface. Every time John Young and Charles Duke went out on a spacewalk, they collected a different type of sample, meticulously cataloging each one. They used specialized tools such as shovels, hammers, and sample tubes to gather rocks and soil. They also employed a lunar drill to extract deeper layers of rock, allowing them to gather more detailed samples that would later provide invaluable insights into the Moon's evolution. One of the most exciting tasks was collecting samples from a lunar rock formation, particularly from different regions of the Descartes Highlands. These samples helped scientists understand the Moon's formation and the processes that shaped its surface over billions of years. During their time on the Moon, Duke and Young weren't just collecting samples, they also observed the distribution of lunar rocks and kept detailed records of their findings. They made sure each sample was carefully numbered and labeled so that future experiments could be done with precision. The low-gravity experiment, jumping on the Moon. Lunar gravity is only about 1/6 of Earth's gravity, which means astronauts can jump around and move much more easily on the Moon. But this difference in gravity was actually an important part of Apollo 16's science experiments. One of the key experiments was the lunar bounce test, where astronauts dropped objects of different weights and observed how they bounced on the Moon's surface. The experiment showed that the Moon's weaker gravity slowed the fall of objects, which deepened scientists' understanding of lunar physics. This research didn't just shed light on the Moon's characteristics, it also provided crucial data for future space missions. Understanding how objects behave in low gravity will be essential when planning for long-term space missions, like living on the Moon or Mars. The laser reflector, measuring distance between the Earth and the Moon. Apollo 16 was also tasked with setting up a laser reflector on the lunar surface. This wasn't just a cool gadget for the astronauts, it would play a pivotal role in measuring the distance between Earth and the Moon with unprecedented accuracy. The reflector, which is still in use today, was part of an experiment designed to measure the relative motion between Earth and the Moon. Scientists shoot laser beams at the reflector and measure how long it takes for the light to return. This data helps them track tiny changes in the Moon's orbit and better understand how the Earth-Moon system evolves over time. This experiment was groundbreaking. It provided astronomers with a tool that still gives valuable data about the Moon's orbit and serves as a model for more advanced space technologies, like laser ranging for satellites and spacecraft. Lunar dust and radiation, a glimpse of the Moon's harsh environment. Apollo 16 astronauts didn't just collect rocks, they also collected tiny lunar particles. These particles, which come from the solar wind and space dust on the Moon's surface, provided clues about the Moon's environment and how it interacts with the space around it. The astronauts also measured the radiation on the Moon's surface. Without an atmosphere to shield them, they were exposed to intense cosmic radiation. These measurements were vital for understanding the Moon's surface environment, which is crucial for planning future lunar exploration missions, especially if humans are going to set up shop on the Moon in the long run. Seismometers, digging deeper into the Moon's interior. As part of the mission, the astronauts also installed crucial geological and seismic instruments, including the lunar seismometer. These devices would measure vibrations caused by moonquakes and other seismic activity, providing valuable data about the Moon's internal structure. These seismometers continued to operate for years after Apollo 16's mission, recording data on the Moon's geology and helping scientists understand what lies beneath its surface. This data has been used not only to learn about the Moon's internal structure but also to help future lunar missions by offering insights into where to place lunar bases. Laser ranging in the modern world. The laser reflector wasn't just an important scientific tool for understanding the Moon's orbit. It also had a huge impact on modern technology. The precision of laser ranging led to improvements in satellite navigation and distance measuring technologies, influencing systems like GPS. Today, the precision of laser ranging helps ensure accurate satellite positioning, which is used in everything from global navigation to weather forecasting and disaster relief operations. Communication, the backbone of space exploration. One of the unsung heroes of Apollo 16 was the deep space communication system, which allowed the astronauts to stay in contact with mission control throughout their journey. Using NASA's Deep Space Network, DSN, Apollo 16's crew was able to maintain continuous communication with Earth, despite the vast distance between them. This communication system, which included high-gain antennas and phased array antennas, helped ensure the success of the mission by providing real-time data and updates. The DSN was a game-changer for deep space exploration, and the lessons learned from Apollo 16 helped lay the groundwork for future missions, like Mars exploration and beyond. Today, the technology is still used in various deep space missions, making it an essential part of space exploration. Final thoughts: a legacy that lasts. Apollo 16 wasn't just about landing on the Moon, it was about pushing the boundaries of what we knew about space. The experiments and samples brought back from the Moon have shaped our understanding of our nearest celestial neighbor and have provided critical insights for future exploration. From laser reflectors to lunar dust, Apollo 16 contributed more than just rocks. It gave us tools to navigate the future of space exploration. And just like that, the mission flew into history, one giant leap for science, one small step toward the stars. Apollo 16, pushing the limits of space exploration and innovation. Let's talk about the real MVP of Apollo 16, the lunar rover. If you thought your car was high-tech, imagine driving on the Moon with zero GPS, no air conditioning, and no road signs. Apollo 16's lunar rover was a game-changer. It wasn't just a cool piece of tech, it was a lifeline for exploring the rugged terrain of the Moon's Descartes Highlands. At the heart of this rover's power system was a revolutionary silver-zinc battery. Back in 1972, this battery technology pushed the boundaries of energy storage. While it had its drawbacks like cost and reliability, it allowed the rover to travel across the Moon's surface and complete scientific experiments. Silver-zinc batteries weren't just about powering vehicles on the Moon, they paved the way for future battery innovations, and today's lithium-ion tech still carries the torch of their original design. These advancements didn't stop with the lunar rover. They had a lasting impact on solar energy storage. Fast forward to today, and you'll see solar panels paired with high-performance batteries, a combo that's driving the clean energy revolution. All of this? It traces back to Apollo 16's breakthrough with battery technology. Life support systems, the backbone of Apollo 16's mission. Life on the Moon sounds like a sci-fi dream, but for the astronauts, it was a tight, confined reality. Apollo 16 wasn't just about exploring new terrain, it was about surviving on an airless, barren world. NASA had to develop a high-efficiency life support system to keep the astronauts alive and well while working long hours in the lunar module. Apollo 16 featured cutting-edge air purification systems, water recycling technologies, and thermal control systems, all of which became the foundation for later space missions, like the International Space Station. But here's the kicker: these systems weren't just for astronauts. The air purification and water recycling tech that Apollo 16 introduced has influenced Earth-based technologies like disaster relief systems and water treatment plants. Think about it, what started on the Moon now helps provide clean water and air in the most challenging conditions on Earth. Moon rocks and materials science, Apollo 16's lasting impact. One of the Apollo 16 mission's most significant contributions was the collection of lunar samples. These rocks weren't just souvenirs from a distant world, they helped revolutionize our understanding of the Moon's geology. Apollo 16 astronauts used advanced techniques like mass spectrometry and X-ray diffraction to analyze these samples. This level of precision set the stage for breakthroughs in materials science, especially in fields like semiconductor manufacturing, nanomaterials, and medical diagnostics. Today, electron microscopy, especially high-resolution scanning and transmission electron microscopes, has its roots in the technologies developed for analyzing Apollo 16's samples. So when you see an electron microscope in action, you're looking at the direct legacy of Apollo 16's meticulous rock research. Automation on the Moon, laying the groundwork for the future. Apollo 16 wasn't just about human exploration. It also saw the deployment of automated tools like seismic sensors and radiation meters. These innovations laid the groundwork for modern space exploration, especially for unmanned missions and robotics. The tools Apollo 16 astronauts used are still influencing the design of today's robots, rovers, and even autonomous vehicles. Whether it's the Mars rovers or industrial robots on Earth, Apollo 16's technology helped spark the evolution of autonomous systems that we rely on in both space and industry today. The Lunar rover, a star on the Moon. Now, let's get back to the Lunar rover. If you thought moon buggies were cool, wait until you hear about Apollo 16's rover. The rover wasn't just a vehicle, it was a tool that allowed astronauts to cover vast stretches of lunar ground, conduct scientific experiments, and collect samples. What made Apollo 16's rover so impressive wasn't just its wheels, it was the massive improvements it had over the Apollo 15 rover. We're talking better power systems, smoother handling, and more comfort for the astronauts. It wasn't just an upgrade, it was a whole new way to think about space exploration. Thanks to Apollo 16, the lunar rover became an integral part of future lunar missions. It gave us the hands-on knowledge needed to push further into the moon and beyond. A bumpy ride, no GPS, no AC, just grit. Okay, so you think the lunar rover is cool? Well, it's not all luxury. Imagine this: no GPS, no air conditioning, and no take a left at the big crater. Apollo 16 astronauts had to rely on their experience and instincts to navigate the moon's bumpy terrain. Forget about smooth highways on the moon, they were rolling over rocky plains, constantly adjusting to the ever-changing surface. It's like driving without a map and hoping for the best. And don't even get me started on comfort. The lunar rover had no heated seats, no sunroof, and definitely no stereo system. The only soundtrack was the sound of their footsteps and the low hum of the rover's wheels on the lunar surface. It was a far cry from a luxury car, but it got the job done and in style. Want to drive the lunar rover? Well, you'll have to wait. So, you think driving the lunar rover sounds like a thrill? Well, unless you're an astronaut, you'll have to wait for the next lunar mission. The moon's traffic laws aren't exactly simple. There are no traffic lights, no parking spaces, and no lane markings, just the wide open expanse of lunar desert. It's the ultimate test of driving by feel, relying on your instincts, and making split-second decisions. The next time you see a picture of the lunar rover, imagine yourself in the driver's seat. It's challenging, it's high stakes, but it's also an adventure of a lifetime. Just like the astronauts of Apollo 16, you've got to rely on your intuition to navigate this no road, no rules terrain. It's not just about getting from point A to point B, it's about surviving and thriving in an environment where everything is alien and unpredictable. The big picture: Apollo 16's tech legacy. Apollo 16 wasn't just a milestone in lunar exploration, it was a testament to human ingenuity and a stepping stone toward our future in space. From advanced battery technologies to life support systems and the lunar rover, Apollo 16 pushed the envelope in ways we're still benefiting from today. The mission taught us valuable lessons that are still impacting space missions, robotics, and even the way we approach technology on Earth. And the best part? It's just the beginning. The technologies, the data, and the innovations sparked by Apollo 16 are still fueling our dreams of venturing further into space. The moon is just one step in humanity's grand adventure across the stars. The people who change the world usually just think one step deeper. If this story made you see things differently, hit like, subscribe, and save it. See you in the next story.